So here we know that delta y from the arrow to the target is 0 meters, so we can use the range equation. We know that delta x is going to be equal to 38.0 meters, and this can also be equal to r. We also know the Vx initial, which equals Vx final, is going to be equal to 23.1 meters per second. Again, there isn't any acceleration in the x direction. So the time in the air is needed. So time equals delta x divided by Vx. So this will be 38.0 meters divided by 23.1 meters per second. And we're getting that t equals 1.645 seconds. 1.645 seconds. Now, we need to find the drop. So y final equals y initial plus vy initial t plus 1 over 2 gt squared. We know that vy initial is 0. We know that y initial is 0. So we can simply say 1/2 of 9.8. 9.8. And then 1.645. Oh, sorry. Apologize. 1.645 squared. And y final will be equal to 13.3. So this is the drop. So if he shoots the arrow at a perfectly horizontally, it's going to hit it's going to be 13.3 meters. It's going to hit 13.3 meters below the target because, again, gravity is going to bring the arrow down. And by finding the time it is in the air, we can find by how much gravity is, rather how long the arrow is in free fall, and essentially how the delta y, essentially the height drop from the initial point. So in order to find the correct angle to fire the arrow from, we can say that r equals v initial squared sine of 2 theta divided by g. So this is the range equation, and then you can simply solve for theta and then use 38 meters for r in order for the arrow to hit the target. So because delta y needs to be 0 meters, we can use the range equation. If we don't shoot it at an angle, it will hit the arrow will hit 13.3 meters below the target. So solving for the angle, we can say 1 over 2, and then we can say arc sine of Rg divided by V initial squared. And so we can solve and say this is going to be 1 over 2 arc sine of the range. So in this case, 38 times g, so 9.8 divided by V initial. So that will be V initial squared, so 23.1 squared. And we find that theta equals 22.1 degrees. So this is the correct angle to shoot the arrow in order to compensate for this 13.3 meter drop and hit the target with the arrow. That is the end of the solution. Thank you for watching.